Hello students, today I have the questions from 31 to 37 of NEET 2019 series H1, and I have told you earlier also that videos are lengthy, approximate of 1 hour. This is because first I have to write the question, then to explain, and then to apply, then to calculate, so it takes time. So don't worry, you watch the video fully, then you can understand that how to solve the numerical asked in the NEET exam. So today I am taking the question from 31 to 37. Question number 31. The time period of geostationary satellites. The time period of geostationary satellites is 24 hours. 4 hours at a height, 6 RE. RE is radius of Earth. The time period of another satellite. The time period of another satellite. Whose height is 2.5. Whose height is 2.5 RE from the surface. From the surface will be. Now your options. First is 12 upon 2.5 h. Second is 6 root 2 h. Third is 12 root 2 h. And fourth is 24 upon 2.5 h. These are the options. Now the solution to this question. You are given the geostationary satellites. There are two satellites at the heights, different heights. One satellite has the time period, and we have to find the time period of the another satellites. So here you know well the Kepler's third law of planetary motion. T square proportional R cube. Kepler's third law of planetary motion. T square proportional R cube. Where this R equal to R plus H. So now you apply this T1 upon T2 square is equal to R1 cube upon R2 cube. Or you find the time period, so T1 upon T2 equal to to square root of R1 cube upon R2 cube. Now here this R1 is equal to 6 RE, height 6 RE. So RE plus 6 RE, this is equal to 7 RE, and R2 is equal to RE plus 2.5 RE, and this is your 3.5 RE. And this T1 24 hours and T2 you have to find. So now put these values. 24 upon T2 equal to square root. R1 is 7 RE, and this is now your 3.5 RE. This is now your whole cube. RE will cancel, and 3.57 to this is now your 2. So 2 cube. 24 upon T2 equal to 2 cube is 8. So now you can have this, or this T2 equal to 24. The square root of 8, it means that 2 root 2. So this will cancel by 6, 12. And then root 2, then this will cancel to 6 root 2. So we will have T2 equal to 6 root 2h. This will be the time period of the second satellites. So our option is second. This is the right answer. This is the second. And now 32. Question number 30. A circuit when connected to an AC source, a circuit when connected to an AC source of 12 volt gives us a current of of 0.2 ampere. The same circuit when connected, the same circuit when connected to a DC source of 12 volt gives a current of current of 0.4 ampere. The circuit is we have to recognize the circuit. First is series LC, second series LR, and third series RC, and fourth the series LC. Series LC. LC तो आगे series LCR. Now solution. You are given the AC circuit, and also just you see from the options that is given the series RL, RC, LCR or this RC. So this is the AC circuit. And in AC part, when we connect the circuit with the AC, then all the three component acts. So they are giving the current of 0.2 ampere. Now what happens? That this XL equal to 2 pi FL. So much of XC 1 upon 2 pi FC. So much of. Now what will happen? That this circuit will operate in the AC. The XL and XC both will act because they have the AC has the frequency. And now here you see that in DC, this XC will not act. SC will not act because F is equal to 0, so X equal to infinity. It means that no current will be allowed in the circuit. So for DC, source Xc equal to infinity. Because you are given the series, so when Xc is equal to infinity, then no current must be in the circuit. No current in the circuit. It means what? That since we are getting the current in the second chance and the first chance also, it means there must be only the two components. The C will not be operated there. So what we have, the C we have to neglect, the C here, C here, C here. So all these first, third and fourth options are not the answer, but our answer is series LR. Because in DC, XL is equal to 0, so this is the ideal resistance. It will allow the path to pass the current. Resistance will also allow to pass the current. But XC will not allow to pass the DC current. So what will? That there will be only two components, L and R. So our answer. The capacitor will not be inserted. It means that our answer is only the second one. This is the second answer. And now question number 33. A cycle wheel of radius 0.5 meter. Cycle wheel of radius 0.5 meter is rotated with constant angular velocity velocity of 10 radian per second, of 10 radian per second in a region of magnetic field, in a 0.1 Tesla, which is perpendicular, to the plane of wheel. Plane of wheel. The EMF generated. The EMF generated between center and ring. Center and ring is. Now the options. First option is 0. Second option is 0.25 volt. And third option is 0.125 volt. And fourth option is 0.5 volt. These are the options. Now solution to this question. You know that the wheel is just like a disc that is rotating in the magnetic field perpendicular to it. So this is suppose the magnetic field, this is the wheel. Then this is being rotated like this or like this. So the induced EMF E equal to BAF. We have the simple formula. B the magnetic field, A the area, F the frequency. So this is your B, A is your pi r square, F is equal to omega upon 2 pi. F omega upon 2 pi. This pi and pi will cancel. So this is B is given to you 0.1, R is given to you 0.5 meter. 0.5 meter. This is now square. Omega, this is given the 10 radian per second. 10, this is upon 2. So this you divide by this one, this is now 5. So this you will do it that this is your 0.25 into 5 into 0.1. So this is 0.125. This is so much good. This is the answer. So our option is third. So our answer is third. So we have a little calculation by applying the formula B equal to BAF. This has to be remembered. The same is in case of rod. When rod is being rotated in the magnetic field perpendicular to it, then the same formula holds there also. Now question number 34. For a transparent medium, the relative permittivity and permeability, the relative permittivity and permeability, epsilon r and mu r. And mu r 1.0 and this is 1.44. Respectively. The velocity of light in this medium would be the velocity of light in this medium would be now first option is 4 point into 10 raised to the power 8 meter per second. Third is 2.5 10 raised to the power 8 meter per second. And third is 3 into 10 to the power 8 meter per second. And now fourth is 2.08 into 10 raised to the power 8 meter per second. These are the options. Now we have the solution of this question. This is the question. If you read it carefully, then this is from the electromagnetic waves. So we have the formula. This C upon V equal to the square root of mu r into epsilon r. You have to find the V. V equal to C upon the square root of mu r epsilon r. So this is now 3 into 10 raised to the power 8 upon this is given to be 1.44 into 1. So this B is equal to 3 into 10 raised to the power 8 and this will be 1.2. It's the square root 1.2. So just you cancel to this one, this decimal, this is 0, then 3 to this is now 4, then this is 2, this is your 5. This to this 2.5. So we get 2.5 into 10 raised to the power 8 meter per second. So our option is second, 2.5. So our answer is 2.5 is second. This is the second option. So just we apply the formula and then have the little calculation and find the value of V. Now question number 35. A sphere encloses an electric dipole with change with charges. Plus minus 3 into 10 raised to the power 8 coulomb. What is the electric flux? What is the electric flux across the sphere? Across the sphere. Now what options are given here? First option is 6 into 10 raised to the power minus 6 Newton meter square per coulomb. Second is minus 3 into 10 raised to the power minus 6 Newton meter square per coulomb. And then third is 0. And now fourth is 3 into 10 raised to power minus 6 Newton meter square per coulomb. Now solution. You have to find the electric flux with the electric dipole. So the students know it that the net charge of the electric dipole is 0, then definitely the electric flux will be 0. So you can do it directly also. The right option is third one. If you want to solution, then we can have from Gauss law. Gauss law, phi equal to q upon epsilon. And for dipole, electric dipole, q is equal to 0. Therefore, phi equal to 0 upon epsilon naught, or this gives you phi equal to 0. So what we have? The right answer is third. Our answer is third. This is a direct application of the Gauss law. Now we come to the question number 36. 36. Two identical capacitors. Two identical capacitors C1 and C2 of equal capacitance capacitances are connected as shown in the circuit. Are connected as shown in the circuit. As shown in the circuit. Terminal A and B. Terminals A and B of the key A and B of the key K are connected. K are connected to charge capacitor C1 to charge capacitor C1 using battery of EMF V volt. Using battery of EMF V volt. Not disconnecting A and B. Now this connecting A and B. The terminals B and C are connected. The terminals B and C are connected. Due to this, what will be the percentage loss? What will be the percentage loss of energy? Now circuit is given here. This is A, this is C, and this is your B. This is B, and here we have capacitor. Then to this we have another capacitor like this. This is C1, this is C2. This is the battery of V volt. And now our options are first 25%, second 75%, third is your 0%, and fourth is 50%. This you have to find the answer. So now solution. Here given the two capacitors C1 and C2 of the same capacitance. So what we have, this C1 equal to C2 equal to C. Let both the capacitors have the same capacitance. This A and B, connecting A and B. Connecting A and B. If both are connected, then this will charge. It will acquire some charge. So the capacitor C1 will charge. So what should be the energy? Energy Ui is equal to half C V square, because the potential difference is V here on this. And now we disconnect A and B and connect B and C. And now what we do? Disconnecting A and B. and connecting B and C. B and C. What will happen? When we disconnect to this one and connect to this C, the whatever charge is here will be redistributed. So this charge, the capacitor C2 will also get charged. Or you can say, since this is the charge body, so when they will connect, then there will be common potential between of these capacitors C1 and C2. So either you find the charge on each that will be equal, or you find the potential that will also be equal. Now here the potential is B, here the potential is 0. So if you find the common potential, it will come out to be half of this one. Half of this one. Common potential. And always remember that when the charge and uncharged bodies are connected, there is the flow of charge. The charge is redistributed according to the in the ratio of their capacitances. So common potential, this B dash equal to C1 B1 plus C2 B2 upon C1 plus C2. Or you can see that this C1 equal to C, B1 equal to B. Whatever is the potential here, that will be same as in this, because it has got the charge from this battery B. Plus C2 is C, B2 is equal to 0, and is either C plus C. So you can see that this is now divided. So B dash equal to B/2. Since this was not charged initially, so the energy of this one will be taken into account when A and B are connected. So now the final energy. Final energy UF is equal to half C1 B dash square plus half C2 B dash square. So this is equal to half C B dash equal to B upon 2 whole square plus 1/2 C into B upon 2 whole square. So this will be your C B square upon 4. So what you find that this energy is just half of this, the initial value. So this is Ui upon 2. How much is the loss? The percentage loss. Delta U upon Ui. This is equal to Ui minus UF upon Ui. Simple formula. Percentage you multiply by U. Then you can find that this is equal to Ui minus Ui upon 2 upon Ui. So this is equal to how much? This is equal to your 50%. If you just calculate, you will find it to be first the 50%. If you do not like to do this question like this one, then you can also do with the help of the redistribution of charges. Since this will get a charge Q, so this charge will be divided between C1 and C2. Then after connecting to B and C, this will have the charge Q/2, this will also have the charge Q/2. So again you can apply the formula half Q square upon C. Even you will get this same thing, that there will be the 50% of loss of the energy. So either you do by the common potential or you do by the redistribution of charge, you will find the same loss of energy. So our option is what? Now fourth. Our option is fourth. And now question number 37. An equiconvex lens is powerful it is cut into two symmetrical halves, cut into two symmetrical halves by a plane containing the principal axis. The power of one part will be. Now options are first, that is to be P, second 0, third P upon 2, and fourth P upon 2. Now the solution. Now what is given here? An equiconvex lens of power P. Equiconvex means that the radii of both the parts are equal, and it is cut into two symmetrical halves by a plane containing the plane. This is the main, the plane containing the principal axis. It means that you are given this equiconvex lens. This is the principal axis. So what we have to cut along to this one? To cut like this, containing the principal axis. So containing the principal axis means then this will be a part like this. These are two halves which are symmetrical. There are two ways of cutting this lens. One is having the principal axis, and second not having the principal axis. Not having the principal axis, then we cut it like this one. So this is, we are cutting the width wise. You can say the width wise. This is the height wise or the length wise. So in this case, since both the surfaces have this spherical part, so they will have again the equal this radii of curvature. So no change in its power. So this is now your we have this, its power is P, then this power is P1, this power is P2. After cutting, radii of curvature. So no change in focal length. Hence P1 equal to P2, this is also equal to P2. So we will have the same here, the power. So our answer is first. So this is what, if suppose this is cut in this way, then definitely this power would have changed, and then the power will be half of the initial one. If we cut it like this, then this power will be half of the initial value. So this is the questions from 31 to 37, and the remaining question from 38 to 45 I will take it in the next lecture. So you study them. Thank you very much.